Let's get a good sketch down for the octagon. Okay, I can draw a really accurate one here, but just do your best, something like that. And then we have a square. Okay, I'm just going to label it actually. So it's going to be A, B, C, D, so on. Right, and then square inside. Something like that. A, B, I, J. And we're told that the sides of the octagon have length 1, which actually means all the sides are going to be 1, the square included. Okay, I might as well label all of them. Right, then I'm interested in CJ and showing that that is equal to root 3. There we go. Okay, so I've got to think carefully about this. How am I going to be able to work out CJ? Well, one thing I notice is that I could create a right-angled triangle like this. So I'll call that point I. It's going to be right-angled, brilliant. Because what I have now is a right-angled triangle over here. And if I drew it here, then I can see it's isosceles. It's going to be, sorry, I didn't say this, did I? But this is 90, and the interior angles of an octagon are 135 degrees. Quickest way is to do 360 divided by 8, which is 45. That's going to be the exterior angle, and then do 180 minus that. So I've got 45 here and 45 here. An isosceles triangle where the hypotenuse is 1. And this means that these sides are 1 over root 2. Okay, if you don't believe me, what you have to do is you have to call them x and do x squared plus x squared is equal to 1. 2x squared, 1 squared, which is just 1. 2x squared is 1. X squared is a half. And therefore x is the square root of a half, which we can write as 1 over root 2. This is actually a little fact worth knowing. Whenever you have something like this, if this was, say, y and y, then you get root 2y. So when it's the other way around and this is y, you get y over root 2 over here. So what have I actually shown? I've shown that this length of my triangle here is actually going to be 1 minus 1 over root 2 because it's the full amount of the square and I'm minusing this length. And then for this length, it's going to be very similar, but now I've got the length of the square, and I'm adding this 1 over root 2. So I can use that to work out CJ. Let me just draw this triangle out again. So I've got 1 plus 1 over root 2, and I've got 1 minus 1 over root 2. And CJ squared, maybe I should put that in a bracket, is going to equal 1 plus 1 over root 2 squared plus 1 minus 1 over root 2 squared. This is actually a double bracket. And so is this one. Okay, the more you practice this, you can actually just expand it straight away from there. It's just important to not just do 1 squared plus a half because there's some cross terms. So I'm going to get 1 plus 1 over root 2 plus another 1 over root 2, which is 2 over root 2, plus 1 over root 2 times 1 over root 2, which is a half. I'm just timesing fractions, 1 times 1 and root 2 times root 2. Then over here, I've got 1, I've got minus 1 over root 2, minus 1 over root 2, so minus 2 over root 2, but then I get another plus a half. So these cancel, the third is gone, and I'm left with 1 plus a half plus 1 plus a half, which is 3. And therefore Cj is going to be the square root of that, and it's equal to 3 as required. Okay, neat question. Let me just show you one other way of doing it. I've just had a little glance at the solutions. Okay, it's a little bit simpler to be fair. So remember, we're interested in this line here. Now, what you can actually do is create a different triangle like this. And then remember, this was 45 degrees. And this is also 45 degrees because it's, we're splitting a square, we're using the diagonal of a square, so we split 90 into 2. So actually we've created a right angle triangle like this. This side length is 1. This side length is going to be, I can use this triangle, which is also right angled. It's going to be 1 squared plus 1 squared square rooted, which is root 2. So Cj is going to be root 2 squared plus 1 squared square rooted, which is root 3. Do you know what? That is much easier. So go with that as the best solution. Mine worked pretty well, just a bit more complicated. But yeah, good to see both.